Greetings, Earthlings! Before we start exploring, don't forget to like, comment, and subscribe, wherever you're listening. It helps more people find the show and supports our mission of making science accessible to everyone. You're here with DJ Stellar Cloud. Thank you for tuning in. Welcome back to the Exploring Your Universe radio show. Exploring Your Universe is UCLA and LA County's largest science event. Every year, we host over 10,000 people, and we have over 500 volunteers and over 70 booths. You will hear about one of those booths today, but Exploring Your Universe is coming up, actually. It is going to be on November 2nd, and so when you're hearing this, it'll be in about a month. You are listening to DJ Stellar Cloud, she, her, and
DJ Lens, he, him.
DJ Lens, aka Devon Williams, is a PhD candidate here in the Astronomy and Astrophysics Department. More importantly, he is the head of outreach for that department. That's crazy, I didn't know that. And as far as EYU goes, he leads the gravity table booth. So I thought all tables had gravity. Please tell us what's going on at gravity table.
So you have this sort of ring-shaped table, and then you attach a sort of fabric sheet around it that's a little bit elastic. Mm-hmm. And so then the idea is that you can sort of mimic the effect of sort of orbits and objects in space by putting weights on the table. And so that will bend the sheet downwards.
Sure, yeah.
And then what you can do is you can sort of roll marbles acting as maybe asteroids or something. And maybe the weight is like a planet. And then you can get these sort of cool orbits where the marble is sort of rolling around on this table around the weights themselves. And that's sort of acting similar to gravity.
So it's quite literally the fabric of space-time.
Literally, yeah, exactly, yeah.
That's fun. How large is this table?
Maybe 2 feet by 2 feet, roughly.
Oh, okay. So it's like sizable where you can have like quite a few kids around it, but it's not like bothering the UCLA events office.
Yeah, exactly, yeah. Sort of like 30 kids crowding the table at once, lined up by height, and they're all throwing their marbles in at once is sort of how it goes, but everyone's having fun, so it's a blast.
That's really cool. Is it just marbles, or do we have other objects? Any non-circular objects, maybe?
Yeah, so most of them are circular except for the weights. The weights normally aren't circular just because you don't really want them to move too much.
Oh, sure. That would be embarrassing.
But you can have a few circular weights. Mm-hmm. And what you can get is that if they're heavy enough, they'll sort of fall into each other, which is also what we see, with objects floating around in space. Eventually, if they're big enough, they can also collide. And so you can get some really interesting effects there.
That's really cool. Something that I've noticed from many booth leaders who have joined us. By the way, last year was your first time as a booth?
Yes. Yeah.
Cool. Anyway, what I was saying was that a lot of booth leaders discuss how children always manage to destroy their booth somehow. They're always the most excited of like, how can we not use this booth for its intended purpose?
Yeah, exactly.
Did you run into any of that?
Not very much destruction. I think a lot of the parts are quite simple. I think most of the issue we had was, kids putting marbles in their mouths, which is quite vile, but
sure.
It's cute. It's normally they're much younger, and so they just don't know that they need to throw it and not eat it. But
yeah, I mean, what I've learned about kids wanting to put things in their mouth was like, this is how they learn about things. Like, taste is also one of their senses.
Yeah.
I grew up with like tons of allergies, so I was not really allowed to put anything in my mouth. So I'm actually slightly envious of these kids. But that's pretty cool. Did anybody really figure out what you were trying to say with this table? Because there's a slight disconnect, I would say, between like your physical fabric of space-time and then the astrophysics, the concept that you're trying to represent. How close did kids get to understanding this?
Yeah, so I would say like, depending on the age group,
sure.
I feel like a good number would understand. So typically what would happen is we would have a sort of rotation of kids, so maybe like 10 kids at a time. And
we're popular.
Yeah, we had a long line at some point. It's But inevitably, one of the kids would, sort of know a bit too much and, of course, reveal all of the fun, exciting bits about the experiment themselves. And so, yeah, there was always one smart kid that would answer all the questions, but you could sort of tell, looking at the other kids, that some message was getting across.
Okay, so there's
gravity.
There's a script.
Yes,
there's some set of questions.
Sort of, yeah.
Can we get a taste of some of the questions?
Yeah,
I'll try to answer them as though I'm a child.
Oh boy. Yeah, so a lot of them are like, what do you think would happen if I roll the marble, sort of slowly? So imagine we have like a table and there's a weight in the center.
Yeah.
What happens if I go too slow? Where does the marble go?
Okay, so if it's too slow, it's going to fall straight into the center?
Yeah, exactly.
Okay.
And then if it's too fast?
Yeah, it'll start circulating. Orbiting? Rotating?
If it's the perfect speed, but what if you go even faster?
I don't know what happens if you go faster.
Yeah, so if you go too fast, the table essentially just acts as a ramp, and then something that we would frequently see operating it is kids would throw it too fast, and it would sort of just bounce right out of the table, and it goes all over the floor.
Like a half pipe?
Exactly.
Got it.
Just like a half pipe, yeah.
Not to embarrass myself too much here, but I was a physics major in college, so I probably should have known that. Anyway, so you talk about how you had like these different age ranges of kids. Mm-hmm. This year there's a new implementation for EYU where you get to choose your ideal age range.
Wow.
Do you know what you would pick?
I don't. I would probably cut out maybe like just the lowest echelon. I think maybe the demo's a bit too, a few too many marbles going into mouths for like toddlers, but
sure.
After that, I feel like most age groups could interact with it reasonably well, I think, yeah.
That's cool. I will keep that in mind. The reason we're implementing this is that a lot of parents of small children don't like walking around the entire event looking for kid-friendly activities.
Yeah.
So this year we're trying to have like Kids Corner, and that's done by DJ Galactic Seagull Natalie Lamb, who we both know.
Yeah.
So she's currently building our map such that people can walk in an accessible way. Do you have any like children that really stood out to you as like, oh, this is the next DJ Lens?
There are definitely two of them. One, I don't know if he'd seen the demo before, but he sort of knew where I was trying to go with sort of every demonstration. One of the things we try to show is if you have like a handful of marbles and you sort of roll them all at once, sort of together, and you try to get them all to orbit, essentially what you'll find is that, you'll have the weight in the center, and then you'll have this group of marbles moving around, and then slowly the ones closest to the center will fall in first.
Sure.
And then it sort of tears apart that ball of marbles that's orbiting, and so it sort of stretches out. And this is what we see in stars. Essentially, if a star goes too close to like a black hole, for example, what happens is it gets literally ripped apart. It sort of gets...
I forget what we call that. I know it's like tidal forces.
Yeah, tidal disruption.
Oh yeah, tidal disruption.
Yeah. And so, of course, when I do this demo, I ask, can you think of an example? And no, it's stars falling into a black hole and stuff.
Seriously?
Yeah, exactly.
Bro, these kids are coming for our jobs.
Really.
All in fun though. That's really cool. I do really like that. Also, you just reminded me that rotating bodies can also be represented with your gravity table, like the full thing.
Yeah, exactly.
So that's really cool. How did you come up with the idea for this booth, if you came up with it?
I did not come up for it. I think it's used by quite a few clubs to explain gravity. I just think there's this very long list of example phenomena that you can demonstrate very well with this table. And so I think a lot of groups from like the Galactic Center group here at UCLA to a lot of groups studying sort of planet dynamics and how planets orbit different systems, it's a very useful tool to demonstrate a lot of these sometimes very subtle or esoteric topics.
Yeah, you're right. Because when you were talking about the marbles, it reminded me of like secular motion and when planets end up in resonances.
Yeah.
That freaks me out so bad.
Yeah, exactly.
I don't like how the planets know that they're integer multiples of each other. Okay, you're the only other person I've known who's agreed that this is freaky. Everybody else is like, come on, it's physics.
No. Physics is my side job.
Really?
Yeah,
okay.
Yeah.
Well, do we have any more fun EYU facts about gravity table before we move on to why physics is your side job?
Not really. I mean, I think it's one of the things I really like about it is that it's not expensive to build. I think a lot of times when I talk to high school teachers or even like middle school teachers is that a lot of times the demos are sort of inaccessible or, hard to build or hard to maintain or expensive to build or maintain.
Yeah.
But I think this, just because it's, just a sort of circle of pipes or tubes and then just like a stretchy sheet that you stretch around it, it's very easy to like put together, build, cheap, and store easily. And so that's one of the really nice things about
DJ Lens and I are currently sitting in the storage room of like $1 million worth of physics demonstrations that were all extremely difficult to build. So that's definitely at the forefront of our minds. But that's a really good point, and this is almost something that people could build at home.
Yeah, exactly. Yeah, that's really fun. It can be your party trick if you have parties at home, I guess. Or you can bring it to the club, I guess.
I would totally bring this to the club, but that really just speaks to what kind of person I am. Are you guys coming back this year? Is Gravity Table going to make a reappearance?
I think so. I mean, I think I was maybe underestimating the amount of participation on the kids' end.
Yeah.
I was a little bit swamped last year with the amount of interest, which is amazing.
I know, it's a good problem to have.
I love showing kids about gravity, but yeah, I think if we do make an appearance, it'll definitely be with 4 or 5 people instead of the 2 we had.
Wait, it was just 2 of you. Okay, was it you and a general volunteer, or like you and a friend?
It was me and a general volunteer, and then an unnamed professor was signed up to present with me, but they
didn't go.
They weren't.
Okay, really cool of them.
We had a really awkward conversation in the elevator about it.
Oh my god.
Yeah.
On the way to this, or no?
No, it was about a week later. Yeah.
Oh.
Yeah. It was a week after.
But can we give a shout out to the general volunteer who stuck it out?
Yeah.
What is their name?
Oh man.
Oh,
I don't know if I remember. Yeah. She was amazing though. She was great.
Thank you to that brave general volunteer who showed up and stood at the gravity table for 5 hours.
Endless hordes of children.
They love gravity.
They really love gravity.
That is one thing I learned in astrophysics. Everybody loves gravity. Well, just like everybody loves gravity. They're like obsessed with it. Anyway, you mentioned that physics is your side job, and I did notice that you listed you were the Department of Astrophysics' outreach person.
Yeah.
How did this happen? What does this mean for you?
Yeah, so in the astrophysics department, we sort of have, the graduate students have sort of jobs that they do, and so everyone signs up for one of the jobs that they like to do. And so we have a bunch of people who work on outreach. Mm-hmm. A lot of people work on the planetarium.
Oh, yeah, we love the planetarium here.
Yeah. And then a lot of people work on like figuring out funding within the university and stuff like that. And so one of the jobs that looked really fun for me was sort of coordinating outreach. Mm-hmm. And so we have a program called Astronomy Live, which...
Yeah, I know a lot about Astronomy Live.
Yeah.
Exploring Your Universe used to be Astronomy Live.
Exactly, yeah.
Do you have the history on this? I'm so curious.
I have a little bit, yeah. So initially, the graduate students in the astronomy department wanted to put on demos for, the community nearby. And so initially it started out as, mostly astrophysics things. And so Explore Your Universe was literally about, the sort of universe you live in, sort of more than just everyday science things. It was more like, galaxies interacting and stuff like that.
Get to know astrophysics. Astronomy.
Yeah, it was sort of more astrophysics and astronomy. And then eventually, the door was opened. We always love participating in these things with other departments. And so, EPSS got in on it, and some, chemistry and biology all wanted to help participate in the community, which is, of course, awesome. Mm-hmm. Exposing kids to more fields is always preferable. So it sort of just grew and grew and grew into this sort of larger program that is now just Explore Your Universe, separate from Astronomy Live. And so now Astronomy Live has sort of shifted its focus more towards taking demos to schools rather than having schools and students, come to the UCLA. And so now our focus is primarily on the schools that can't really afford to do sort of field trips and schools visits places. In the United States, we have this sort of system called Title I schools, where if at least, 40% of the students come from low-income families, they have this sort of specialized classification and get specialized funding. And so we try to prioritize visiting and taking demos to these Title I schools to expose these kids to astrophysics and physics at large. And that's something that's really important to me because, I wouldn't be doing astrophysics today if someone didn't, come to my school and be like, hey, astrophysics is something that, you can study.
Really?
Yeah.
That is cool. Before we get into that, I did want to tell you that, or not tell you, tell the audience that we do bus in a few Title I schools every year. So this year my goal is 5. Last year we hit 4. This year our goal is 5 with the budget cuts of 2025.
That's impressive though, still.
So we're going to try our best. We're definitely going to hit 4 this year. 2 I think have already confirmed, and we do have the money for 2.
That's amazing.
But that's really cool. Is Astronomy Live like a regularly occurring thing then?
Yeah, so we try to do like 2 visits each quarter is like our goal.
That's so much for PhD students.
Yeah, exactly. It's all led by graduate students. There's no, sort of department external funding or anything like that.
Thanks a lot, guys.
Yeah. It's good fun. I think whenever you take the demo and just see the kids' reactions, it's always like it's payment enough, I guess. Yeah.
That's true. But speaking of kids' reactions, you mentioned that somebody Astronomy Lived you when you were little.
Yes. Yeah. So in high school, I sort of had the maybe common position that, at the end of high school, I have to decide what I'm going to do in college, a billion things that I could study. And so I sort of just ended up having the stance that I'll just choose whatever is, least boring at the time. And so for me, that was physics.
Okay.
So I was like, oh, I guess I'll study physics. And then before I graduated high school, there was someone who gave a talk in my physics class about astrophysics. And then they were just talking about, what it's like as an astrophysics student. And they were studying at the University of Chicago at the time. And that sort of made me realize, like, oh, there are more things to study than, simple harmonic oscillators, which no one, really study. Well, I shouldn't say that, maybe.
No, this sounds a lot like my life story, and I'm pretty sure I meme out simple harmonic oscillation on here all the time. Just because I think it's funny. I don't know. The simple harmonic oscillator, the block on the wedge. This morning, my brother texted me about e to the I theta.
Mm-hmm.
And he's like, man, I really messed up. I put the wrong thing on my e to the I theta exam. And I'm like, sorry, that's actually the only thing you have to learn.
Yep.
That is really cool, though. Did your high school physics teacher sort of coordinate these talks in the classroom, or this person just happened to stop by?
I think it was just like an offhand visit. I mean, my high school physics teacher was, pretty cool guy.
Mm-hmm.
He was really fun to talk to. Very quirky. Soon discovering that that's just most people who do physics. But no, I think his personality definitely participated quite a bit in me wanting to do physics. And I think that was just the sort of cherry on top, is that, some people study galaxies, and that's something that I can actively do.
Yeah, that's very cool. When you said something people actively do, I immediately started thinking of active galaxies. And this is almost like astronomy brain rot.
It really is, yeah.
Like, we keep saying words to each other, and then they get associated with, like, nearby astronomy terms.
Yeah.
Really silly. Anyway, so you mentioned that physics is your side job. Is your main job then this outreach coordinator thing, or?
No.
There's more.
I just,
DJ Lens is multifaceted.
I love facets. I really do. I think currently I'm in a very privileged position, I think, just in general in the world. I go to grad school in Los Angeles. The weather is, well, recently it's been bad, but generally
I love it. I'm from here. This was perfect.
Really?
Yeah.
The humidity has been, oh my God. I don't pay for humidity in my rent. I mean, the weather is, typically 72 degrees, sunny every single day, and not a cloud in the sky. Like, I don't have a lot to worry about, and so I try to spend a lot of my time, filling it with hobbies or going on walks, looking at birds. Birds are super cool.
Okay, favorite bird watching app?
I mean, Merlin.
Okay.
Merlin, of course.
Merlin has been mentioned many times on this radio show. There's
really?
The Venn diagram between EYU radio show guests and Merlin users is a circle.
Yeah, absolutely. That app is incredible. Very few things bring me as much joy as, like, ending up in some weird place. Like, last week I was in Peru, for example.
Yeah.
I don't know anything about the birds in Peru.
Sure.
I like to know that I know most of the common birds in California. There was not a single bird that I could recognize in Peru, but that app was,
amazing.
Oh my God.
The biodiversity of the world.
It's incredible. And they're able to identify them from, like, so far away. Like, awful audio. Like, I'm by the busiest road of my life, loud as can be. And, one chirp and it knows what bird it is. It's an incredible app.
That is really cool. So your main job is being present in the moment.
Yes.
Okay.
As corny as it sounds, I do enjoy that quite a bit.
The other day, I put on my Instagram leave a note, because I'm no longer on X.
Mm-hmm.
The moment is like the valley. I don't know anyone who lives there.
Yeah.
But now I do know someone who lives there.
Yeah.
Very cool, DJ Lens.
I try to. I don't know if I visit.
Well, your main gig is trying to live in the moment.
Yes.
It is a full-time job.
Yeah. I'm not often successful. And when I'm not successful, we fall back on our night job, which is astrophysics.
Sure.
Yeah.
How did you pick DJ Lens as a DJ name?
I figured it was probably closest to what I do for my research, and so I think it was most what I would embody if I were a DJ talking about gravitational lensing.
Oh my gosh. Okay, I just put it all together. Gravity table, lens, gravitational lensing. We are now on to talking about your side gig.
My side gig, yeah.
Okay, what is gravitational
Night
lensing?
job.
People need to know.
Yeah, of course. So, this sort of not very well-known physicist came up with this kind of crazy theory that when things are very heavy, the space around them actually sort of knows that, and it changes. Space-time itself changes. And the way things in that space experience space and time changes as well. This was the big discovery of, general relativity by good old Albert Einstein. And one of the really cool things about this is that, similar to the gravity table, if you have a very heavy object, it sort of bends the space around it. That's also what we see when we look at, big galaxies. If there's a galaxy, it's extremely heavy. And let's say we had a very bright, flashlight or candle behind that galaxy.
Mm-hmm.
If you're the correct distance away, what you'd see is that the light from that candle or flashlight would be able to sort of bend around that galaxy. So if you can imagine if, let's say there's a valley in between me and the person in front of me or whatever, and so there's a sort of downhill slope in front of me and a sort of uphill slope to get to them or whatever. And I roll a bunch of marbles. Essentially, I can roll a marble a bit to the right and a bit to the left, and maybe they'll roll and, hit the person in front of me, traveling two different paths.
Mm-hmm.
And so that's sort of what we observe with the light around these galaxies. So instead of the light traveling straight through, normally galaxies are very bright, and so you wouldn't be able to see it.
Mm-hmm.
What you get is the light travels outwards, bends around the galaxy, and then you're able to see it sort of next to the galaxy, if that makes sense.
Yeah, this effect is visible in some of our most famous images. I'm thinking about that James Webb JWST deep field image that was shown recently, where you have some mirror images of galactic objects. Sorry, cosmological objects. I don't know the word for this.
Sure, yeah.
That appear twice. I was showing this to my grandpa because he actually really wanted me to be an astronomer, and finally I can explain stuff like this. So this is one of my favorites because it's crazily advanced physics topic that you can actually see.
Yeah.
How did you get interested in this? How did you join your current group?
I mean, I'm going to keep it a stack. I applied to graduate schools, a bunch of places. There's sort of two I was deciding between, and the advisor at the other school turned out to be sort of a not great advisor or person for me personally.
Okay.
And so I decided to come to UCLA, and at UCLA, the main professor who wanted to work with me was my current advisor, Tommaso Treju.
I hear great things about this person.
Yeah, he's a very funny Italian man. Hilarious guy. But he works on gravitational lensing, and he's sort of, one of the world experts in gravitational lensing. Very, very big name.
So you followed the people as opposed to, the topic.
Yeah. I mean, I was pretty confident I would want to do something with galaxies in some shape or form. But what the specific details were, I wasn't super... invested in one topic or another. I'm sort of more of the stance that, if you find someone that is very fun to be around, I'm sure you could,
You'll
maybe
learn to
empathetically or sympathetically love to do their research as well. Yeah.
Very cool. Was the other school you were trying to decide between UCSD?
No, it was University of Chicago, actually.
Oh, okay. Yeah. Well, there's somebody else there who I also don't like, but they don't do galaxy stuff.
Famous character.
Unrelated.
Fantastic books. Many books wheeled out. Yeah,
it's always the book writers.
It's always the book writers. They bring them everywhere.
Yes.
In wagons.
Love that for them. I can't wait until I'm doing that and people are like, DJ Stellar Cloud is so annoying. She always has her books on her. But it's just children's books on EYU or something.
Oh, that'd be fun though.
Yeah.
I wouldn't mind a children's book. It's always, some... yeah.
Anyway, what specifically with gravitational lensing do you research?
Yeah, so one of the really cool things about gravitational lensing is that, well, maybe more generally an issue in astrophysics is that distances are extremely hard.
Yes.
If I have a bunch of kids out for a night sky show and I ask them which star is the farthest,
they might pick the smallest one. But
they'll probably pick the smallest one, and then, the follow-up is always, well, some stars are just smaller than other stars. So how do you know that's the farthest? Not particularly clear.
And then that one guy who already knew everything about gravitational lensing will know which star it is because they have the whole map memorized.
Yeah, exactly. The whole night sky is, memorized. So one of the nice things about gravitational lensing is that you can imagine maybe you have a really stretched out triangle where the distance between us and like that flashlight is sort of the really long arm of the triangle. Mm-hmm. And then there's a little bump somewhere near the center, maybe, of the triangle. And so you can imagine if a light is following that path, so it's traveling out from the flashlight and then, you know, moves a little bit around the galaxy between us, and then comes all the way back to us. You sort of have the geometry of a triangle, and so there's a bunch of very silly math tricks you can do.
The small angle approximation.
Yeah, small angle approximation, all of our favorites.
Is this related to parallax?
Rules. Similar to parallax,
okay.
a little bit different, just because, the objects aren't really moving, per se.
Yeah.
At the distances that we're looking at, things never really move. So if you can imagine, if you imagine, staring out at, the farthest galaxy that we can see, its position on the sky wouldn't really move, even though that galaxy is, moving through space and stuff like that. It's sort of fixed on the sky because it's so far away.
I'm laughing because we finally have a guest who is as blasé about astrophysics as I am.
Mm-hmm.
Everybody else is like, this is so exciting, everything's so far away, I'm very excited about these light year distances. And we're just like, you've got a bumpy little triangle, which means that we can skip all these extra Taylor expansion terms.
Yeah, exactly. But so this triangle shape is essentially a useful tool for measuring distances.
Mm-hmm.
And so if you have a really bright object that sort of fluctuates in brightness,
mm-hmm.
a really cool thing is that if there's multiple images, so let's say there's one image that's bending on the left side of the galaxy, mm-hmm. another image that's coming from the right side of the galaxy, and then maybe one from the top and one from the bottom. So there's 4 images.
Mm-hmm.
The objects we typically study are called quasars, so this would be like a quadruply imaged quasar, mm-hmm. is what I specifically study.
Oh, okay. Quasars are the loudest AGN?
Yes. Okay. So they're essentially, I guess for people that don't do astrophysics, so if you imagine a black hole,
mm-hmm.
lots of energy, lots of stuff moving very quickly around them.
Yeah.
And so if you imagine...
People have seen the Katie Bowman image. You have this,
exactly.
the ring of orange spaghetti around everything.
Yeah, or Interstellar, right?
Oh, I've never seen Interstellar.
Really?
Yeah.
Really?
Again, very blasé about astrophysics. Can't be bothered.
No, that's okay. I'm the same way. Yeah, so imagine a bunch of dust swirling around this black hole. The speed that you have to move in order to orbit has to be extremely fast, and so there's lots of friction, lots of heat, the black
mm-hmm.
holes, radiating energy and stuff like that. And so all this friction and heat actually makes it the brightest thing we know of. Quasars are by far the most luminous objects in the universe. And this is very nice for what I do because that means you can see them from extremely far away. And so if we're able to get, a flashlight very far away,
mm-hmm.
and we're able to measure the distance of that flashlight, that's very, very useful for measuring things like, how fast the universe is expanding, which is the main question that I tackle.
Very cool.
Yeah. So essentially, so if this quasar sort of fluctuates in brightness,
mm-hmm.
you can imagine each of the different paths that
mm-hmm.
light is taking to reach your eye are probably different lengths.
Mm-hmm.
And so you can imagine if, because light travels at a fixed speed, one of the light paths is going to hit you before the other one hits you. So if there's a flare up in brightness, you'll see that flare up in one image,
mm-hmm.
and then maybe a week later or a month later, you'll see a flare up in the other image. And so you can sort of think about it say you have a snail race.
Yeah.
And there's 4 different paths that the snails take.
Mm-hmm.
Some of them are longer. And let's say all the snails move the same speed.
Mm-hmm.
Whoever reached the finish line just depends on who takes the shortest path for the most part.
Yeah. This is a very common thing in special relativity too, the path length difference.
Exactly, yeah.
Very cool. I think you did a great job explaining one of physics' hardest topics in a way that everybody will understand.
Hopefully.
I love snails. Great stuff. Anything else about your research that you want to share with our audience?
Not really. It's a really fun topic.
Mm-hmm.
Most of my day-to-day work is sort of just looking at, I can't really complain. James Webb's
beautiful images.
JWST images from of these beautiful galaxies with, extremely bright objects around them. And it's it's some of the coolest images that James Webb has released. But yeah, fun stuff.
Thank you so much for sharing that. Our final question that everybody gets asked is, if you were a small child at EYU, very small DJ lens, what would that be? A DJ piece of glass dust?
Sure.
And you were at EYU and you're maybe not super excited about everything, but looking for something that's the least boring. What would you have wanted one of the adults to say to little DJ Lens?
If I was looking for...
Just anything. Some people ask please give me a snack. Have you seen Drag Race? Because this is the question that RuPaul asked the queens when they're all finalists.
Okay. Yeah. I'd probably ask for a 20. I think if I was a kid,
yeah,
I could probably get quite a few 20s from some adults.
This is so funny. You better redonate them to the org.
if I was a kid, I'd probably be taking it, but
What the heck do kids have to spend money on?
I don't know.
Okay.
I mean, I like to think back, like back when I had an allowance.
Yeah.
I have no clue where that money went.
Okay.
I can't remember.
So you would have wanted the volunteers of EYU to, like, be willing to give you money?
Yeah.
Okay.
That would be nice.
Okay. Because if we had invested that back in, like, the early 2000s, we could afford housing in LA.
Probably, yeah.
Yeah. This is good financial advice. You know, this is our first reach into finances, but I like it. Where can people keep up with you, your research, your outreach, your actual job?
Yeah, so my Instagram is probably the only place you'll find me.
Okay.
Well, I have a website too, but I mean, even finding me there is probably... I don't post very often.
Okay.
But my Instagram is Devon, Devon, period, and then was, period, taken.
Mm-hmm.
I really wanted the name Devon, but...
But somebody took it. It's not related to you, like, being abducted or anything.
No.
Okay.
It's a common misconception. And then I think if you Google me,
mm-hmm.
I'm sure my name would come. If you put like Devon Williams UCLA.
Yeah.
You might have to put astronomy. There's like a basketball player or something. Of course, always a basketball player at UCLA, or maybe it's a football player. And so you might have to do Devon Williams.
Yeah.
UCLA astronomy.
Yeah. Similarly with me, everybody's name is my name.
Yeah. There's quite a few.
Very cool. Thank you so much for joining us. Are there any last words you would like to share with our listeners?
No. Thank you so much for having me.
Yeah, thank you for joining us. This has been DJ Stellar Cloud and
DJ Lens.
Never Stop Exploring.